Let's start with whatever we have done and then we will move for the next one. So squares 1 4 9 16 25 36 49 64 81 100 121 144 169 196 225 256 289 324 361 400 441 484 529 576 625. So the one in which I used to 17 square 289, 18 square 324, 19 square 361, 21 square 441, 22 square 484, 23 square 529, 24 square 576, 24 square 576, 23 square 529. Cube 1 8 27 64 125 216 343 5 112 729 1000 1331 1278 2197 2197 2197 2744 3375 4096 4913 5832 6859 1331 1278 2197 2197 2197 2197 2744 3375 4096 4913 5832 6859. Let's do one more time. So 1331 1278 2197 2197 2197 2197 3375 2744 2744 14 cube 2744 14 cube 2744, then 17 cube 4913, 17 cube 4913, 17 cube 4913, 18 cube 5832, 18 cube 5832, 18 cube 5832, 18 cube 5832, 19 cube 6859, 19 cube 6859, 19 cube 6859. Done. So then mirror, it was the formula. And yeah, in this one, as I was having some issue doing the calculation, so I came up with one idea how to, this is between 25 to 50. Yeah, so there's one different trick which I found. Yeah, see, let's just try to accommodate how. Okay, give me some time, I will try to accommodate everything. If it's taking too much time, then I will just fast forward. Great. So I feel remembering or using this one is easy, but this one is difficult. It takes time and a lot of thinking we have to do. So let's try to find out something else. So the equation right now, it looks like z square equal to b square plus z minus b upon 2 into 100. And as we already know that b is nothing but 50 minus z. So can we write z equal to 50 minus b? replace here z square equal to b square plus, instead of z we will write 50 minus b minus of b divided by 2 into 100, and this will become z square equal to b square plus 25 minus b, 25 minus b into 100. So here also it is in the form of 25 plus b if it's more than 50, and if it's less than 50 z is between z is between 25 to 50. This is the newer one, or this is the updated one which I'm going to use for now onwards. So here was our formula, so we have to change it. Let's change the formula. Yeah. Great. So the important points we can highlight. Now it's kind of very easy. If it's less than 50, 25 minus b, more than 50, 25 plus b. Once it above 75, like right now it is in the domain of 50, like multiplication of 50 is easy. But when it's domain of more than 75, or when it's in the domain of 100, nothing, z minus b, z plus b, that's all. So doing the calculation now is kind of easy. So yeah, in the meantime let's do the revision, as we already revised this one. Okay, yeah, this is also important. If the 10th digit is similar and the sum of unit place of the digit is 10, then how to do it? 10th place 8 similar, unit place 8 plus 2 10, so nothing but 8 into 2 16, and then 8 plus 1, that is 9 into 8 72. So we have done difference is even. So when difference is even, suppose here 84 plus 86, 86, the difference is 2, so it can be written as 85 minus 1 or 85 minus 2. In this format I can write 85 equal to 85, 84 equal to 85 minus 1, 86 equal to 85 plus 1. So in this case it's kind of easy. Mistakes which I used to 43 41. So yeah, these places less than 50, I notice a lot of mistakes I am doing, and I guess because of that z minus b upon something 2. So this was kind of irritating, or it will take time, or there's a possibility of more errors. So now it's easy. So let's try to find out the value of 42 square with the newer formula now. So 42 square, so 42 square, z would be 8, 8 is what, 64, plus now 8 plus 25, 25 plus 8, how I can write 25 plus 5 plus 3, 25 plus 5 30, 30 plus 3 33, so 3364. Oh shit, still I'm doing the mistake. Oh okay, my bad, I think Again, I don't know why. Wrong. I need to highlight this, that I am doing wrong again and again. 42 square, new formula, 8 square plus, now less than 50, then 25 minus 8. 25 minus 8 will be 25 minus 5 is 20, and then minus 3 17. 1700, 1764. Yeah, 1764, it's correct now. So the mistakes which I am keep on doing, that will be, I suppose, removed with the help of practice. If I practice enough, I suppose this all mistakes will be gone. Yeah, this is homework, guys. Yeah, once I completed this homework, so we will do again. This homework will always continue, revision part and the homework part series I will always going to upload, but for the time being, let's move to the next topic. So yeah, last class, what I skipped or what I haven't done, but from now onwards I will do revision done, question done, multiplication done. Oh, great then. There's one more thing which I will add in the homework, new homework I will going to add after this class. So till now we have learned everything about like how to do the squarings. So let's try to understand now the applications of squaring. So as the new topic is starting, let's bring the big, let's do one thing. Headland will always be known in terms of how to underline it. I don't even know. I think this is good. That's enough. It's good. Yeah. So we are we are doing now applications of squaring. So the first thing is which we are going to do is last two digit pattern. We're going to observe this, like let's just try with example. Suppose I take 17 square is 289, and if I just say 15 minus 17 square, this is what, 33 square. 33 square, let's try to calculate with my new method. 33 289, and then 25 minus 17, that is 800 plus this will be 1089. Coming to the next one, it will be 50 plus 70. Let's try to do this one, 67 square. So in this context, I will add 25 plus 17. So it will be something 25 plus 7 32 42 4200, and then this one 4489. Sorry, 4489. So that's also correct. And then let's try to solve 100 minus 17 square. So it will be 83 square. So 83 square, how we will calculate? 17 square plus 83 minus 17. So 83 minus 17 will be 83 minus 3, 80. Then 80 minus 14 is 66. 6600 plus 289. 66 and 68. 66, 68, 89. 68, 89. And similarly, if I do 400 plus 17 square, it will be 117 square. That is nothing but 17 to the 34. 34 plus 2, 36. 13689. So now I don't need to use any pen. I can easily solve with my mental capability. But yeah, I accept that it is taking some time, but with practice I suppose this will also be done in no time. So what one thing which I am noticing here is the last two digit, that is 89, no matter in which condition I am taking, last two digit is always in the form of 89. So let's take one more example. Generally okay, let's take one more example of series of let's take 16. So 16 square is 256. 50 minus 16 square sorry, 34 square. So 16 256, and then 25, 16 4 9 9 9 1156. 1156. 50 plus 16 square equal to 66 square. So 16 plus 25, 41. 4100. 4356. 4356. 100 minus 16 will be 84. 84. So this will be 84 minus 14. 84 minus 4 first of all. So it will be 80. Then 80 minus 2 is 78. 72. 78 minus 10 is 68. So 6800 plus 256. 6800 and 256 is 7056. Correct. Then 100 plus 16 square, 116 square. So 116 to the 32. 32 plus 2, 34. 13456. 13456. So again, what I can notice over here is the last two digit is 56. So there is a rule. Let me write in the red pen. I will write main points only in the red pen. That 1 square x square between 25 square. Yeah. So whatever number I am choosing, or wait, let me just write it in the new page. One square x square 25 square. So what actually happening, if x square is between 1 to 25, so if x square has the last two digit as a and b, then 50 minus x square will also have will also have a and b as the last two digit. Similarly, with 50 plus x square will also have the last two digit as a and b. And if I continue this, 100 minus x square also will have the last two digit, and 100 plus x square will also have the last two digit at a and b. So this is the rule. Let's try to understand from how and where this came. So let's try to and not only this one, this will continue to all, sorry, this will continue to all the multiple of 50. So all the multiple of 50 minus x or plus x, they will be having the same uh, last digit no matter what. So first of all, let's try to understand why is this happening, and if someone could start thinking this 50, why is this 50 unique, I suppose a lot of answer is already provided here. Yeah. Why I chose this 50, so that would already see. Let's try, or if I can, I'll try to copy this one. Copy. Paste. Yeah, great. So in this condition, let's see what is z, what is b. Let me use this different color pen. I suppose this green is also visible. What is this b? B is nothing but 50 minus z. Can we see is this is the same form? Is this is the same form 50 minus x? Let's do first of all this one. Okay, everyone knows x square will have a and b. Okay, now let's come to 50 minus x square form. So here is what 50 minus z. This is the form. This is the real form for it, and to which we are writing b as b square. Okay, and b square is what? To here it is x. 50 minus x whole square, we know x square. Similarly, to z we can write as in this form. Z can be written as, okay, right, yeah. So b is what? 50, difference from 50. Or if I want to write z equal to 50 minus b, so 50 minus b, here 50 minus x, b square x square. So it's in the same form. Or if not, if you want me to correct it for the reference, I will write x, I will change here also with x, I will change here everything, every b with x, such that it will be easy to understand. Okay, so I can write here equal to z equal to 50 minus x in this context. Okay, if z is between this one, so this is what? Only this thing, and this part, no matter what is the value of it, will be integer, and integer into 100. Suppose it came as y, so y 100, last two digit is not going to affect. What is going to affect is last two digit of x square. Whatever is the last two digit of x square, the same will be for the z square. Similarly, if we see in this case, and if this case also we replace it with x square 25, just yeah, Okay, in this context also, if you see in that form, everything is here multiplied with 100. So no matter what is this, what is this, what is this, every place we can see that it is depending upon the b square, because this is going to what, the last two digit will always be 100. Suppose here let's 29 square. So 29 square, how we are going to write? 29 is what, difference from 50 is 24. Okay, then 24 square plus 24 square, and then what I am, the new formula, 25 minus 1, 25 minus 24, wait, to, sorry, 29 minus 24, 29 minus 25 into 100. This is our new formula. So what is happening here, this is what, 576, wait, this will be 21, right? This will be 21, 25 minus 21. As this is the new formula, I'm having some, like, it will take some time for me. Okay, let's just cross check. X square, correct? 25 minus x, 25 minus x into 100. Go, great. So 21 is what, 21 square is what, 21 square is 441. So 441 plus what is happen, 4 into 100. So can is it easy to see? 29 square is what, 400 plus 441. So does this going to change anything? No, this is going to change. 41 will be there, 841. Okay, and this 41 is, we know that between 21 to we can write this as 21, and 29 can be written in the format of 50 minus 21 square. 21 square we know 441. So 41 is the last digit which is same in both the condition. So this is what I am trying to imply over here. So let's just solve some question and understand. Let's just solve some question. With the help of the question, we will slowly understand how is it going to help. So one question, let me just write it. First question is, find the last two digit. First one is 89 square. So if you ask anyone else, like any normal guy who doesn't have that much knowledge, so that person can easily say, okay, 89 is 9 square, so we know 9 is 81, so last digit will be 1, correct? But what about the tens digit? We don't know anything about the 10 digit, no? But in this context, 89, we know what is 89. 89 is what, 100 minus 11, and we know 11, last two digit of 11 square is what, 121. So the last two digit of 89 square, last two digit is what, 21. This is the answer. Or because, yeah, one more thing, why we took 100, because 89 is closer to 100. And one more thing, if anyone wants, okay, now that you have told me last two digit, why don't you tell me the whole square? So let's try to find out also. So 89 is 129, then 89 minus 11 will be 78, I suppose. 78 100 plus 121, 79 21. Correct. Now I feel it's easy for us to solve any question, and let's see if it's the same for others also, or not. Let's try to solve for more. Like this 11, let's take all the value of 11. 50 minus 11 square, it will be what, 39 square. So 39 is what, then still 11 square 121, and then we have to remove from 25. We don't have to add, adding is after 50. So 25 minus 11 is what? 14. 1400 and 1521. 1521. Still the last two digit is 21. Let's solve for 50 plus 11. That is 61 square. 61 is what? In this context, 25 plus 11. That is what? 36. 36 plus 37. 21. Yeah, correct. This is also having 21 at the end. 100 minus 11 will be the next, which we already calculated. 89 square is what? 7929. 7921. Sorry, 7921. Same. Coming to the next one will be 100 plus 11 square. This is what? 111 square. What it will be? 1 2 3 2 1. Yeah. So in this context it's also correct. If it's clear, let's move to my next question. Next question is find last two digit of 113 square. So we don't even need to look or think anything. What is it? 100 plus 13. 13 is 169. Last two digit is 69. It should not take more than a second, but still let's try to see how it will be. 100 plus 13 square, 69. Okay, but let's try to write in the beginning. 113 square is close to, it is close to 100. It is close to 100, and the difference is how much? Difference of 13, and it will follow the series of 13. So this will have the same as 13 square. 13 square is what? 69. Last two digits, so answer is 69. Correct. Let's try to solve more questions. Last two digits of 166 square. So again, easy question. If you want shortcut, it is nothing but 150 plus 16 square. 16 square is 256. Last two digit is what? 5 and 6. Done. But for the sake of understanding, let's just write it. 166 square is equal to, it is close to 150. The difference is 16, so it will follow the series of 16. If it is follow the series of 16, then 116 will also be same as 16 square, that is having last two digits 5 and 6. So let's take some bigger number. Let's see if it works on those or not. Last two digits of 232. Okay, so 232 square is it is close to 250. The difference is what? 18. So it will follow the series of 18. So 232 will be same as 18 square. 18 square. So 18 is last two digit of 18 is what? 64. 324. So 24 will be the answer. Let's let's take some more bigger questions. Last two digits of 689, how much it will be? So again we can rewrite is at 689 square, it is close to 700. Okay, and the difference is difference of 11. So it will follow the series of, it will follow the series of 11. So it will also have same as 11 square, that is what, 21. Great. Now that we can solve this type of question, let's try to increase the level of difficulty of the question. So question is, how many perfect squares up to 1 lakh will end in 44, or let's not take 44, let's take some different value. 24. So the common mistake which I am going to show solution. First of all, let's do the common mistake. This is not the solution. Let me tell you again, this is a common mistake. People could not understand this line. How many perfect square up to 1 lakh? So people start thinking, okay, up to 10 lakh, how many numbers up to 1? See, this is the perfect square up to 1 lakh. This is perfect square up to 1 lakh, not for the number. So what majority of people will think, okay, what, that till 1 lakh, how many numbers are there to which we will square, and last digit will be 24. That is the totally wrong understanding, and the approach they will do, oh, 24, they will start thinking 24 in which square it will come. So again, revision: 1 2 3 4 5 25 36 49 64. No, 24 is there. Then 81 100 21 12 44 13 69 14 96 15 25 16 56 256 17 89, then 18. Okay, 18 square is what, 324. Okay, let's check if there is any more. 19 square, which I always used to forget, is what, 19 square is 361. Okay, 361. Let's solve this question. Then 20 400 21 441 22 484 23 529 24 576 25. So there is only one number, 18 square. So what people will think, okay, from 1 to 100, how many squares are there? So first will be 24 square. Okay, then 50 minus 24 square will also have the same format. We just learned 50 plus 24 will also follow the same thing. 100 minus 24 will also follow the same thing, but 100 plus 24 is more than 100. So what we can derive here is, there are four squares till 100 which is having the last digit as 24. So up to the 4 lakh, how many will be there? So let's just write four numbers between 1 to 100 whose square contains 24 as last two digits. But this is okay. And what they will do, if 1 to 100 is this much, so total number will be 1 lakh divided by 100 into 4 to 2. So they will say answer is 4000 and they will be happy. But let me tell you, this is wrong. Now this whole is wrong, because question is about squares, perfect squares up to 1 lakh. So what actually should be the approach for this question? The approach for this question should be, so again the starting was correct, that real, let me just write it, correct solution. Correct solution. So the correct solution is, we know that 18 square is 324, but this square, we know that till what was our last, till 1 lakh. So we have to remember one this. So x square is equal to 1 lakh. 1 lakh. So the nearest x square, okay, because we know that little bit of things we can imagine is 3000 square is 90,000. Okay, and but still there are numbers between them. So the nearest square which I would suggest to remember is 316 square. 316 square is what? 99856. This we should remember. I think it's better to do with red color. Try to remember this. Yeah. So as of now, we already know that 316. Okay. So we know that 316 square is 99856. If we increase this 317 square, then it will surely surpass 1 lakh. So all the squares before 316 we need to find, for which the last two digit is what? 24. So that is totally easy. So from 0 to 100 there are 4. If you ask me what are those 4, then I can say you 18 square, then 50 minus 18 square, 50 plus 18 square, 100 minus 18 square. So these 4. So similarly from 101 to 200 there will be 4. Again if you ask me the same counting I will do. 100 plus 18, 150 minus 18, 150 plus 18, 200 minus 18. So 201 to 300 there will be again 4. But the moment I will start moving from 301 to 316, there are none, 0. So total number of square for this one will be 12. 12 will be the answer for this question. So I hope that this kind of concepts is easy. So similarly there is one more question. Let's try to solve that. How many how many 5-digit perfect squares will end in 89. So the question is little bit of tricky and different this time around as well. So the first thing first is what? 89, last digit of 89. So again try to recall. So once you remember the square till 25, then it will be easy for you to remember that 17 square is what? 289. And if 17 we know that, then 17 square 289. 50 minus 17 square will be 33 square, I suppose. Yeah, 33 square we just calculated 1089. 15 plus 17 square is what? 67 square. 25 plus 13 4489. Then this will also 100 minus 17 square is what? 83 square, which is 6889. But there is a condition now. There is a condition that 5-digit perfect. How many 5-digit? So 5-digit, the domain or the 5-digit perfect square will be from 1 2 3 4 5 till 1 2 3 4 5. So we already have this knowledge. 1 2 3 4 5, this is nothing but 100 square, correct? And 9 9 9 9 9, we know that the nearest to this is what? Nearest to this number is 316 square is 99856, which we have to remember. So now the question is, how many perfect squares are between 100 to 316? And we know that 17. So 300 plus 17 will have the last digit as 89. But this is not, we have to find between 100 to 306, because this one will be more than 99999, which is not 5-digit. Okay, it will exceed the 5-digit, so it cannot be possible. So 100, between 100 to 200 will be 4. 201 to 300 will again be 4. So total number of 5-digit square will be 4 plus 4, that is 8. Once this is done, there is one more good question, that is how many perfect square are of the form AABB. So this question seems kind of confusing. AABB. So as of now, how many perfect squares of this form AABB? And yeah, one condition is there. Perfect square is of 4 digits, only 4 digits. Okay, that is also visible 1 2 3 4, but just for the clarification I just written over here. Now what we will do, so first of all, this confusing thing is we don't have any idea regarding this, that we are not so sure, we are not so sure about this. So let's just leave it for some time. But 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 we can we can we can say we can say for surely we can say for surely that it is that it is either it it should be between 1 to 1 square 25 square only. So again, recall what are the different squares. So if I recall nicely different squares, 1 square is 1, so this is only one value, so it's not possible. So similarly, if we see, then 10 square will be 100, last two digits are same. Then copy to this, 20 square is 400, last two digits are same. And in the meanwhile, what I just skipped is 12 square is 144. So last two digit of these three number till 25, they have the last two digit number are similar. So let's just tackle this first of all. So if we tackle about first case, that is 10 square 100, 20 square 400, 30 square 900, 40 square 1600. So it should be between 4 digits. So is 1 6 equal? No. Come to the next one, 50, 2500, 5 to equal? No. 60 square 3600, no equal. 70 square 4900, equal? No equal. 80 square 6400, equal? No equal. 90 square is 8100, equal? No equal. And if you go to 100 square, then it will 1 2 3 4 5, these two are equal, but this is again 5 digit, so it's not possible. So we can say that it's not in the series of 100, neither in the series of 20. So what is left? 12. Let's try with the 12 now. So we know that 12 square is 144. Similarly, in that form, 50 minus 12 square, it will be 38. I suppose, yeah, 38. So 38 square is what? 25 minus 12 is what? 1300. So 1444. 1444. These two are equal, but these two are not equal. It's fine. 50 plus 12 square, let's take that, will be 62 square. 25 plus 12, it will be 25 plus 12, 27, 37, 37, 38, 44. Are these two equal? No equal. 100 minus 12 square, and it will be 88 square. 88 square is what? 88 minus 12 is what? 76, and 77, 44. We can see this is equal. This is in the form of AA, BB, and yeah, we will not go beyond 100 plus 12. Okay, why? Because 100 is already in the 5 digits, so 100 plus 12 will also in the 5 digit. So the correct answer for this question, so only one is possible. So for this session we will end here. Okay, in the next session we will solve some more question and we'll do more exercises.